Good afternoon, everyone, and welcome to another series of IFC webinars. Today, we're going to be graced with Chief Mike O'Brien, who's going to talk to us about how batteries are changing our fire environment. Before we begin, audio is being broadcast using the Voice over Internet Protocol technologies through your computer speakers or headset. Please make sure that your speakers or headsets are turned on and the volume is turned up. Audience microphones have been muted. If you're experiencing any technical difficulties, please contact IAFC support at webinars@iafc.org or via the chat function on your webinar today. The chat, Q&A, and handouts are available in the top right-hand corner of your screen. Please, we encourage you to share your comments and submit questions for our speaker today. If the presenter have been provided with some resource materials, which are in your handouts, you can also download those at your pleasure throughout the event. Today, our speaker and presenter is Fire Chief Mike O'Brien, International Director for the IAFC. Chief O'Brien is the Fire Chief for Brighton Area Fire Protection Authority in Michigan, and that's his contact information, and he'll greatly take in any emails reference this topic. And I'm going to pass it over to Chief O'Brien to take us through today's event.
Thank you, Richard. And good afternoon or good morning to everybody. And a special shout out to our friends in the Spokane Valley who are in a battery work group right now dialing in. As part of this, we greatly appreciate you all being here. We're going to start with a poll that we're going to throw up here. And really the question is, has your fire department responded to a battery-related incident? Pretty simple, yes or no. So a little bit of interactive, but we want to try to get a feel as we talk through this pretty large topic of how batteries are affecting our response. And really today is while we're waiting for this poll to go. Really, we want to make sure we're talking about how do you equip your firefighters, your workforce, your company officers to be better prepared in not only responding to maybe mobility devices, EV incidents, energy storage, or just batteries in general. All right, we're going to close that poll here and just kind of see. So out of everybody here, about 60% have responded to a battery. So we're going to follow up right away with another one. What kind of battery was it? So you've got personal electronics, so phones, computers, EV or a hybrid, energy storage, mobility device such as a bike, a scooter, a golf cart, or maybe some of the other. I know we're seeing some like RC cars that some of those that are falling in. And really, while we're waiting for that poll to kind of close up here, what we also want to do is make sure that you kind of have some action that you can take back home, some best practices, because one of the things that we've really been working on within the IFC is to help educate the fire service in this response category. And we're finding that a lot of people are looking for actionable steps. So we're going to talk about those. So that poll has closed. And it looks like a lot of personal electronic, which is what we're seeing across the country, 13 or 10% on EV, 10% on hybrid. Okay. About 8% on energy storage. 34% on mobility device. Wow. Okay. Very interesting. And we're going to come back to the polls in a little bit, but one of the key focuses too that we're going to talk about very specifically with energy storage systems and electronic vehicles is this defensive stance towards a fire and when to let it burn. Probably one of the hardest things us as fire chiefs with our staff have to make sure we're taking care of. When we look at batteries, here recently, obviously, with the presidential priorities and the desired changes, we're seeing more battery production in the United States, and we have probably billions of dollars in projects on the books as people are working to make different chemistries, different battery types, different cell technology. But it all starts with raw materials, regardless if it's going in a personal mobility device or whether it's ending up in an EV. There's raw materials. And it's kind of like baking, but it has to do with science, right? We take an anode and a cathode, we put it in a container with an electrolyte, and we make batteries. As part of that process, we test the batteries to make sure, at least for the most part, they should be tested to make sure that they're properly functioning as desired. They put the batteries usually in some kind of package. Some might refer to it as a module. And then it gets put into the vehicle, puts into an energy storage system, and it's used. Then you hit end of life, and it may be from it's just not used anymore to maybe it's not charging well. And then we have to start to collect, await recycle, transfer to a recycling facility, and get it out the door. And really, one of the things that we're seeing, and when I say we, I have the just absolute benefit of working with a great group who, under the previous president of the IFC, President Subing, started an IFC work group on lithium ion batteries. And we've been meeting about every 2 to 3 weeks, really working to develop a toolkit that we hope will be out in early 2023. But we've created 2 resources that are in the handouts for you. And as we've kind of been studying and working with fire chiefs and learning from incident responses all across the world, really they seem to be falling into a couple areas. We have this mobility consumer grade device problem. We have these e-bike scooters that maybe the batteries and cells don't quite meet a product standard. They're damaged. They have a thermal runaway event, and they're causing just devastating incidents all across the United States. And some are getting more attention than others, but there is no doubt that this is happening all across the United States. We have the electrical hybrid vehicle, and I would put in that category all sorts of things, such as buses, delivery vans, anything that, is intended for transportation. And then we're getting what I would dub as secondary events. So it could be part of intended recycling, where batteries are being transported to a final recycling, or they've been inappropriately disposed of, thrown away, and then creating us a problem at, say, a transfer facility or in the movement of trash. We have energy storage systems, which I think everybody sees. These are just really long events that we've had some that have been absolutely horrific to our firefighters, as well as storage and manufacturing incidents as well. Now, it's important, right, that not all batteries create fires. Look around your office, look around this meeting right now. You have a cell phone, a computer that has multiple types of batteries that are being used, and they work really well for us, right? It's when we start to have something go awry within the battery or the cell that we're going to talk about in a couple slides. But look at our fire department apparatus now. We're utilizing less generators, and we're putting in more LED portable lighting because of this robust power. I don't know, but do you remember when your fire department switched from maybe a battery-powered Sawzall from a corded Sawzall for vehicle extrication, or better yet, battery, jaws of life equipment, hydraulic tools that are now more powerful than probably your reeled jaws? I mean, really, we see a huge potential, but there's a lot we're learning in the fire service, and not only our operational response, but some of the things in care and maintenance that we need to talking through. And I think it's important. This is a great slide that was really from the Dyson School of Design Engineering. And really, a lot of our incidents are falling into a couple different things. We can have mechanical abuse. Maybe a battery is dropped. We could have something crushed. We could have something penetrate. Right? An electrical abuse, maybe it's an internal short circuit, an overcharge, an undercharge. And then we can have something called thermal abuse, right? Where maybe extreme temperatures, we have a collapse of the separator. But any of these things can lead us to thermal runaway. And thermal runaway can present in a couple different ways. A single cell, right? It might just be what appears to be some light smoke, right? It could be light smoke with a wisp of fire. Or in some cases, you're getting popping in others, or what might seem as an explosion, as what we've seen in some of the buildup of products of combustion in ESS containers, really before the newest standards came into play. But there's no doubt that batteries are affecting us in more than one different way. If you look at the left, every one of those gray boxes is a energy storage system awaiting to be installed. Now, the cool thing about this is, a lot of studies have been done, and all of those energy storage systems awaiting install are less than 30% state of charge. That's an important thing because really we don't see the same fire development as we do when it's above. But in this case, these are energy storage systems awaiting to be installed, but it was a fire ancillary to those that involved multiple pallets, which just created a different fire environment. If you look in the bottom right, it's your favorite big box retailer. And if you've noticed, I think everybody may or may not have seen the most recent videos coming out of the lawnmower show. But a good portion of the lawnmowers at the lawnmower show and our big box are no longer gasoline powered. They are battery powered, and you're going to continue to see this transition. It's hard to go into many of our big box and still buy maybe a gas powered weed whip, a gas powered chainsaw. We're seeing more and more battery in all levels of really our life. And here in Michigan, and I think much of our areas that are seeing vehicle development, we're starting to see more and more facilities which are supporting automotive, which are supporting the battery creation. So it's easy when we think of maybe the Gigafactory that is a battery plant. But what we don't always think about is all the things that go to supporting that battery plant, from movement of raw materials to moving of finished battery packs, all the way into recycling and how we transport products that maybe don't meet our product design standard. And so we can start to see where batteries are really starting to affect. And our concern within the fire service is when we hit one of those three reasons, right? Maybe it's an internal defect, maybe it's damage, who knows? But when a cell goes into thermal runaway, it's really one of the risks that we can't necessarily stop. And part of what we see is this ejection of gas, shrapnel, particulates, and it's very violent at times. And it's at extremely high temperatures that's usually followed with smoke and fire. And when we look at our response, I can tell you just in our jurisdiction alone of multiple fire incidents where mobility devices maybe weren't the cause of the incident, but they were involved in the incident. And now the question is, what do we do? So for the most part, for those of us who live in suburbia, when we've had a mobility device that's been involved in maybe a room and contents fire, a room fire, whatever it may be, a garage fire, we typically get those contents outside of the structure and we just finish extinguishing. You know, battery fires from a sense of extinguishing are typically done with water. There's a lot of things that are for sale that are unproven, but for the most part, we've got to get it outside the structure. For those of you in cities like the city of New York or large metros, your response profile for mobility devices, especially in your mid to high rise buildings, are not so easy in getting that outside of the structure. But for most of us, it's getting those things that were involved outside the structure, continuing your fire suppression operations and continuing to soak the device. Now, one of the things that we have to look at in our non-EV related after the fire incident, so non-EV, non-ESS, this mobility devices, is we don't want this product to create us a secondary incident. And so there's some homework here. If you got to jot a note down, this is a great time to have a dialogue within your community of what's the proper way to dispose of a battery pack, a scooter that's been involved in a thermal runaway event and is not going to create you what I would call a secondary event. So secondary event is on the surface, you could be like, well, we soaked it. It's up to the homeowner, get it out, put it out in the trash. Well, now that secondary event could be maybe all the cells didn't go into thermal runaway. Maybe the soaking didn't do what we needed it to do, and it's now compacted in the back of a compaction garbage truck. And now we have a garbage truck incident down the road. So really, one of the questions we need to have here is what are our options in getting that product within our community properly packaged for transportation so it can end up in recycling. One of the things too that's also very important to note, especially as the size and capacity in golf carts, lawnmowers get more and more, the length of this incident will continue to rise. And so that pre-response coordination is key, right? If you've been on a lawnmower fire, it's a 20-minute, probably, I don't even know if 20 minutes, it's a 10-minute incident. And if we probably had a battery riding a lawnmower, it's quite possible that that's going to be a significantly longer event because we need to A, make sure it's properly cooled. We need to B, make sure it's extinguished, but we've got to watch for those temperatures to come down. And it wouldn't be uncommon for it to present a lot like an EV fire. Now, the IFC in this handout on the right is in your handouts queue. and I hope you'll go grab it. One of the first things that the safety and health section and the fire life safety section of the IFC put out was this response to EV fires. And really, what it was trying to do is take what is the dialogue we need to take. There's a lot of good resources in fighting vehicle fires, especially electric vehicle fires, from NFPA to the manufacturer's webpage to programs like this. And really, this guide is a chief's guide, a recipe card for the discussions that need to take place, because there's some changes that we need to think about. First and foremost is, regardless of our suppression tactics or defensive strategy, this is a longer event, right? So when we look at the manufacturer, when we look at the response guides, when the battery pack is involved, and we're going to put water on it, or we're going to let it burn out and just cool with a defensive stance, this is probably a 2-hour incident. So I want you to think about your fire department right now. You have maybe a little bit of freeway with no hydrant access on the freeway. And right, you send maybe 2 people in a fire truck, maybe 4 people, and they roll up on that scene. That's a 20-30-minute incident, including waiting for a wrecker. This is now, you're going to see as we talk through this, a multiple hour incident that we've got to make sure we're preparing. Now, it's important for us to understand that each manufacturer uses a little different chemistry, although there's about 5 major types of lithium chemistries right now, but they all have their own preferred way, right? And every single one of our manufacturers are making some pretty cool products. If you were to get in this new GM Denali that they just released, it is a sweet looking car, right? And they are making phenomenal things. And at some point 10 years down the road, we're going to have figured out how to extinguish all of these vehicles on a much more frequent and probably more routine basis. But right now, we're going to give you what the best practice is. But it's important to know that each one kind of has their own engineering and how the battery pack's laid out, as well as their chemistry and the like. Now, the fire service, we've done a pretty good job over the years when we start to talk batteries that we care about the amount of electrolyte within the cells. In the case of lithium ion, it's really negligible in the overall discussion how much electrolyte is in the cells versus the older chemistries. But really what's important here is look at these battery packs in different ways, right? This is the battery pack that's been removed from this vehicle up top, and the mechanics are doing some work on the product, and they're going to end up putting it back in place. But that is underneath the vehicle. So on most of our electric vehicles right now, when you open the hood, you might see a 12-volt battery, and that's about it. For the most part, you now have a front trunk. And so that access space and really the power for our vehicle comes in from underneath. Every single one of our manufacturers is creating and has pretty much agreed to follow the same protocol for emergency response guides. This is what is really cool. So if you type in Ford emergency response guides, Tesla emergency response guides, you will find every single one of their electric vehicles in very specific. It's really important that you continue to go back to the manufacturer because they update these from time to time, and you want the most current. In that response guide that we published within the IFC, we linked directly to NFPA, who did a wonderful job early on building the old database. But there's been so many new EV vehicles. It's really important that you create a system within your community for how you're going to gain access. And trust me, there's times I keep thinking that I'm going to have a 3-ring binder just for this. But I've heard of fire departments that are utilizing iPad technology and they've downloaded an app. I've heard of fire departments that are taking the links and putting them as an icon on their CAD computers. There's a lot of ways, but that's really a challenge for you, is how can we get these response guides in the hands of our responding firefighters early? So here's a good example. If you see, excuse me, the yellow here, yellow-orange, that is the high voltage battery pack. And there is one thing at play, and all the manufacturers have agreed that the high voltage cables are orange, and we're never to cut those orange cables. But you'll see here on the F-150, it gives you a pretty good schematic of where that battery pack is. Now, keep in mind, when we have a current gasoline-powered vehicle fire, and that engine compartment is on fire, we cut open the hood, we pop the latch, we put water on it. In this case, look at where that battery pack is. There is no direct application for where or how we can get water on the cells if they're on fire inside or on thermal runaway inside of the pack when the pack is intact. Here we'll look at a different example. This is the Hummer. You can see the size of that. The front and back are the modules for the motor and driving that vehicle. But again, you can see where that lies on this vehicle. Here's the Rivian, both the delivery van as well as their pickup truck. You can get a good example of where that battery pack is. And really for us in pre-response, does your organization have a good, robust policy that's going to start? And I think in part, one of the things that the fire service has really learned over the last couple of years is creating a standard methodology for our first arriving company officers. Their job is complex, but when we create a battle rhythm on every incident, we can get to probably pretty good results. And what I would say is if you adopt some of these basic concepts on all of your vehicle fires, regardless, you can create a rhythm, especially for your crews coming in to support not only in vehicle fires, but on vehicle extrications. So it's very important that you have some very broad conversations with your firefighters. But don't be afraid just to start by going to your dealers and saying, hey, look, Ford dealer, GM dealer, Tesla dealer, we would love to bring our crews through. And we would love for you just to show us the basic operation, how to put the vehicle in park, how the vehicle goes into drive, any of those things, because I think it's really important because we're seeing this really robust change in how our vehicles operate and where they're going. In that training, we've got to just get our staff comfortable with how these vehicles go forward and backwards, how the windows come down. And so that general understanding is key. Now, in this pre-incident response, we collectively with our command staff, down to our company officers, need to have a discussion on this. When are we going to let an electrical vehicle burn? And I hope to give you some parameters here shortly. But once we come up with our strategy, chiefs, you've got to get to city management. You've got to get to your elected leaders and let them know that your crews are going to be tied up longer. You've got to let them know that you're going to see different tactics and because it's going to look odd and clunky with multiple fire engines on the side of the freeway and crews not actively working to suppress a vehicle fire. And so there's dialogue. Maybe it needs to be with our law enforcement partners. It's dialogue that needs to be with our Department of Transportation because these 30-minute incidents now could go into 2 hours, and that's important. Also, creating that strong partnership with your towing company in that idea that we can eliminate secondary responses. Towing vehicles inappropriately can lead to a secondary incident, both while towing or at the tow yard. So make sure we continue in that pre-incident response. And the vehicle manufacturer's response guides are going to help you out, but they all have some very standard items within it, both vehicle extrication, vehicle fire, towing, and submerged vehicle. But here is some important thing, and this is from Rivian. Rivian believes that electric vehicle fires are best addressed with defensive firefighting and management of the environment to minimize risk. Only attempt to extinguish a fire if you have a specific need to do so. So compartment fires are still compartment fires. Put them out. Right? But if the battery pack has been involved, consider if there's no exposures, there's no human involvement, that we're going to approach a defensive measure and just work on cooling and maybe putting out some spot fires. You can see here, right? Some people say, well, Mike, I've seen overseas that in Europe, they like to take the car and put it in a dumpster. Well, you're going to create yourself a unique secondary incident, but here's one of the manufacturers, and it says, do not submerge the vehicle to extinguish, cool the battery fire. And you can see on theirs that we need to use large amounts of water, that it's highly likely that we're going to get a reignition, and we need to monitor that battery for 24 hours. Okay. So when the vehicle is on all fours, it wasn't involved in an impact, and our battery pack is caught on fire, no exposures, no human, cooling around and just really letting the vehicle go and that battery pack do its thing might be the best answer. Now, if it's been in a horrific crash, there's a human trap, there's exposures, you're going to dump copious amounts of water over a long period of time. So, everybody do this right now. I want you to think about areas within your community that maybe do not have hydrants, because this is an easy thing for us to answer when we do have hydrants. But we have rural communities on the call, we have communities that have freeway response. So if you have a freeway response that doesn't have readily access and you're in typical urban fire engines with 500 gallons, this manufacturer is saying it's taking 3,000 to 8,000 gallons. Now do the math. How many fire engines do you need if you need 8,000 gallons of water over the next 2 hours, right? So you're probably going to need 3, 4, 5 engines to cycle through. So you're going to have one engine on scene pumping, you'll have a second one filling up their tank while the other two are running to go get water from a hydrant and come back down onto the freeway if we're going to be actively cooling and working on this fire. So I need you to think about that, because that is a vital thing. Now, this shouldn't be new to us if we needed to get 10,000 gallons of water for maybe a tanker incident that might be, or a big semi. There's lots there that we probably have in our toolbox, but it's a great chance for us to sit here and say, hey, company officers, when you get this, here's what we would like to see. Now, here's another example that high voltage, a battery on fire will not explode. A battery on fire will not explode. If battery reaches high enough temperatures, they vent and release electrolyte. Battery electrolyte is flammable. Gases from the battery pack are toxic. So it's so vital that we really make sure our crews are in full PPE with SCBA and face piece. The white smoke coming off is filled with flammable gases. And one thing that's very important to share with our law enforcement partners, the answer here is look at the bottom, use copious amounts of water, ... Do not use an ABC dry chem fire extinguisher because it will not extinguish the battery fire. So if there's a human trapped and that's what they think they can do to maybe keep the fire at bay, so be it. But for the most part, right, we need copious amounts of water. And so in the process, right, some key items for sure, when we can, follow the high voltage disconnect procedures that each manufacturer has. Each manufacturer has a different way for disconnecting. Now, it's important that when you make the cuts on these loops, you're not getting rid of the stored energy. What you're doing is really starting to make the vehicle inoperable. It's not doing, we're not getting rid of the electricity. It's always to be treated as high voltage. So in a nutshell, and we're going to go through a pretty typical what our company officers are going to see, but a defensive firefighting with lots of water, right? Entrapment, we would want to be actively putting as much water on that vehicle as possible while our crews perform vehicle extrication. There's a difference when it's in the compartment versus the battery pack. And the battery pack's going to show from out the bottom. There's relief holes and vent holes where the smoke and gases are going to come out of. Heck, some of our manufacturers are even having where the cells will come out the bottom onto the roadway or the parking lot. That's a good thing to get us access. If the battery pack's been ripped open and we have direct access on that battery pack, by all means, put water on it. You will probably be done with that incident much sooner. Now, what happens if the charger's involved? And I think that's a key point we're going to hit here in a couple slides. And how do we keep vehicles from rolling away? So, so chalking our vehicles every time that we can is really important. Now, vehicles with exposure, let's just take, it's one thing if it's vehicle to vehicle propagation, maybe in a parking deck, maybe in a parking lot. But what about when it's in an attached garage to a home and we're having issues where that is leading to exposure fires? And so it's really important that if we can, let's get that vehicle out of the garage. Now, I think most of you within your fire service career have had a point in time where you've had a fire within a garage. In that fire in the garage, you needed to get the vehicles out, and you towed them out, you winched them out, whatever it is. It's a little different just to get those out of the structure. But if it's an active vehicle fire in the garage, we're going to have to work to put it out. But here's a key concept. Are we really extinguishing a battery pack fire? And I think it's important that we really try to utilize the words cooling, because once the cell goes into thermal runaway, we can't stop that cell. The key is, can we stop it from spreading to the next cell or the next module or the next event? And so when we're looking at these battery packages, just keep in mind, and all of our training should really be, we are working to cool the fire environment, not suppress the cells. They have everything the fire triangle needs to sustain combustion on their own. And once we get that fire, or we think the fire's out, during overhaul, do not make contact with the high voltage. Never attempt to open the battery pack or cut open the battery pack to make. Buying something to puncture the battery pack is not a good idea and is really against any of the manufacturer's recommendations. And as always, any small fires not involving the high voltage battery pack, put it out like you normally would. So let's talk about this here, because I want to give this battle rhythm that I think is important for our company officers, right? First and foremost, appropriate PPE. Make sure you have the right amount of resources going to the incident, and make sure when we get up to the event, full face piece with SCBA, appropriate size handline. So as our crews approach, fend off, protect your roadway, protect your incident. Very coordinated. One of the first things we should do, that company officers should be doing a hot lap, inner and outer circles, looking for other hazards, looking for the hazards and the type of vehicle. So think blue card for those of you that are blue card, right? That 360 lap, what are we looking for? Occupants, entrapments, people that are trapped in the house, in a basement, right? And we want to reply back. I think we need to create that battle rhythm with our company officers, that on our vehicle fires, they're going to do a hot lap and identify the combustion of the vehicle, right? Or how that vehicle is powered. And if they feel it's an EV, that is a great topic to relay to not only maybe our battalion chiefs, our other companies coming in, but they can start to frame up this incident and support you appropriately, who probably have their hands full on a first arriving electric vehicle fire. So that outer circle, we need to make sure that we identify, is the battery pack involved? Is the vehicle still in a charge state? Like, is it still plugged in? And I think these are just some things, right? So if it is an EV fire and we feel that, hey, we've got to go with cooling here, make sure you've requested the appropriate resources that you've decided on based on that pre-incident review. Now, cribbing the vehicle or securing or chalking the wheels should become a priority. And I think probably most of us in the fire service, we've really gotten away from this. And we've all seen vehicles roll away from us, and they don't have to be electric to roll away. But really, I think now more than ever, we need to get back to cribbing those front and back early on. And then if we have exposures, human straps, secure large water, secure resources, because this is more than one engine, right? If you're going to have people in air packs, you can't have one crew in an air pack for 2 hours. It's going to be multiple hours. And I hope that everybody responding, or every vehicle responding, has a thermal imaging camera to it. And so cool that battery pack and extinguish. And so we're going to have to get a little bit creative to get underneath. There's lots of demonstrations where people have taken maybe their jaws and slightly picked up the vehicle, crib, pulled the jaws away, and we're able to spray on the underside a little bit better. But if that battery pack is really impact or is still together, it's difficult to get water where you need it. So use that thermal imaging camera on the pack after you think the fire event is done. So there's no more smoke. You're not hearing hissing or popping. You're not smelling anything. Basically, at this point, you have about 45 minutes that you got to make sure that there's been no change. Use your thermal imaging camera, look at that temperature setting, and most of the manufacturers are saying somewhere under 200 degrees Fahrenheit. So make sure that you're under that 200 degrees Fahrenheit. And once we've hit that 45 minutes, now we trigger who we're going to call to haul that vehicle off appropriately per the manufacturer's requirements. Because if they do not tow that vehicle right, we're going to create a secondary event, and that's going to tie up crews for even longer. So when that crew, for instance, when that car is now lifted and put on the flatbed, have that crew again with a thermal imaging camera check that temperature on that battery pack. Some of the manufacturers are recommending that when there's been a fire event, that the fire crew follow. And that's really up to your protocols. Should they follow to the yard? And if not, I really think you're going to start to see more of our towing companies utilizing more thermal imaging cameras, because really once we offload, we need to probably spot check that battery pack one more time to make sure we didn't see any fluctuations in temperature. So the key here, and this is out of one of the guides, the battery must be monitored for at least 1 hour. Most of them are saying 45 minutes. Smoke or steam indicate that the battery is still heating. Do not release the vehicle to second responders, such as law enforcement and towing personnel, until there has been no heating detected for an hour. So post-incident, right, it's how do we get this vehicle to not create us a secondary event? And really, when we look, one thing to have a good discussion with is to talk with our law enforcement partners and find out if they are actually storing vehicles inside post-incident for an investigation. And so I think it's really important. One of the questions that I see popped in here, Scott, am I aware of any examples of dispatch considerations Q&A? What I will say is this: I think it's really important that we need to start identifying resources early in all of our vehicle types. But one thing that can be relayed is from OnStar with GM. So if it is an OnStar and it is GM, have them inquire, is this a battery vehicle? Obviously, we know Tesla. If it's Tesla, it's all battery. But let's be realistic. The amount of battery vehicles that are going to be on our roads over the next 2-3 years, right? The incident type is just going to increase in this category. But I haven't seen anything reference Pro Q&A, but a great partner to have a conversation and express to them why this is important to you, right? It's going to slow down our vehicle extrication. We're going to need more resources, and we need to make sure that they're on board. Last week we did a whole topic on submersion of vehicles. Just know that if you weren't on our webinar last week with Florida, there is a whole bunch of resources in every manufacturer as it relates to vehicle submersion. And I really just wanted to point that out. Whether it's saltwater or whether it's freshwater, we're going to have an issue when our battery packs get submerged. And there's a couple key components. Never attempt to charge the high voltage battery that's ever been submerged or is gurgling or gargling or any of those. And make sure that you're partnering with your tow removal agencies. Now, a couple questions here with charging. So this is where a true integration of our prevention staff, our building code enforcement folks, community planners, as well as our operations folks. All of our charging infrastructure is obviously really growing, and it's growing at a very fast pace. How we shut off, right? So if we have a vehicle that is actively charging and it catches on fire, one of the things that we need to do is make sure that we shut off power to the charging, right? So identifying where the disconnects are, identifying where the power shutoff is for the charging equipment on our pre-incident plans is a plus. Now, one of the things that we have to be careful of, in order to make our charging infrastructure really start to work, what we need to do is begin to, well, I shouldn't say we, but what some of the manufacturers are starting to do is incorporate batteries into the charging equipment. So charging equipment is some of the new technology that we're really going to see. Now, it's really important that just as these are going in, that they're meeting their appropriate standards, that they're being permitted for their install. We're doing our part in making sure that they're protected with bollards, that they're that they have all the necessary safety precautions built into them, and then that we're doing something about this. So take like the Tesla. If you go to Tesla Responder, you'll be able to see they have an emergency guide for that piece of equipment, just like they do their vehicles, which is a really cool thing. Or an F, you asked about the car fire blanket. And I think one of the things with the car fire blanket is this. I think it has its opportunity to be utilized, but it's not going to extinguish the fire for you. And whether or not we use a blanket, and one of the things that came up within most of the manufacturers, they say, don't use foam. Okay. So we don't want to use foam because the gas coming off of a cell thermal runaway is highly flammable and combustible. Okay. And if we encapsulate that, we could create ourselves a bigger issue. The same can go with the blanket. Now, the blanket does a great job of limiting our impact on adjacent things, but it doesn't extinguish our fire. And so it's really important that when you go to lift the blanket back off, that you realize that that is highly flammable gas that's underneath that blanket. And I think more is going to come out on the blanket as we go through. Now, switching gears, a couple things that can come into play. When we have vehicles off-gassing, and it's inside of a container like a garage with a door closed, that space is filling up with a flammable gas. Now, think about it. If we take that battery pack and instead of it being in a car, and we put it on a wall to support our building infrastructure, which is happening all across the United States, we can have very similar issues, right? The packs and batteries that go into EVs are very similar to the batteries that go into energy storage systems. Now, energy storage systems have some different testing standards, just like automotive have different standards for how their vehicle is going to be. But the cells, the lithium ion cells, are very similar, and they go into thermal runaway the same way. So in your handouts, we have a guide here for you that really starts to talk about energy storage systems as well and how they are impacting our crew's response. And there's a big difference between those we're putting in single family dwellings versus those that are part of a massive grid support and on a maybe out in a field, out in a desert, wherever they may be. And when I say grid support, these are the size of semi-trailers, and there's 50 to 100 of them supporting the grid. Drastically different response. And so we have a guide here that's hopefully going to help. But when you look at these battery packs, whether they're in a garage, on the outside of a dwelling, part of commercial support, they have a response guide as well, depending on the manufacturer. And most of them will say something like this: the fire crew should allow the battery itself to burn out, during which it's recommended to apply water to the exposures. So really, you're taking a defensive posture and you're protecting the exposure. We don't ever want crews going into walk-in units. We don't ever want to see crews taking apart ESS systems. That's really intended to be a complete package, right? So applying water to the directly to the affected enclosure will not stop the thermal runaway event, as the fire will be located behind several layers of steel, and direct application of water is shown to only delay the eventual combustion of the entire unit. So think about this. One home could have 3-4 ESS units. It's been tested per a standard. And if one of them has a fire event, our goal is to take a defensive approach, keep the area well ventilated, and really start to cool the adjacent. Again, anytime we're in dealing with anything battery related, full PPE with face piece is required. Hopefully, if you have pre-incident data, how you can shut off power to the energy storage system, but you'll see in the guide, specifically when we get out of the residential setting, when we've identified that an energy storage system is in place, identify the manufacturer and get on the phone and let them tell you what the battery management system is telling you. And that lithium ion battery thermal runaway is going to present very similar. It's that white gas, the same thing we would see in an EV fire, we're going to see or would see in an ESS system. And it is important that due to the construction of many of these, the thermal imaging cameras probably aren't going to give us a great view. So a couple reminders. When we have a venting ESS, which is, I think most of us on this call, if you're a firefighter, you would rather go to a fire where there are flames showing from a window versus smoke coming out of a lot of the home, and you've got to go try to figure out where the smoke is coming from. If we're going to a venting ESS, both maybe in a residential garage, in a commercial setting, evacuate the area. Never open any doors or remove any panels to the ESS. Get on the phone with vendor-specific technical support. If your community doesn't have a pre-incident plan program, let this be a reason to get one in place so it's right there at your company officer's fingertips. Residential units that are located in the dwelling unit or the garage, the space should be properly ventilated with charged hand lines in place. So you can't put right now, well, if somebody makes one, you could, but ESS will not end up right now in habitable spaces. But take a basement where I have a utility space within a basement, it could be in there. How do I properly ventilate this space? And it's a tactical consideration that we need to do. Think about what a perfect world we might live in as building and fire permit new ESS installs, that it's put in our CAD computer so it's flagged as a potential energy source when our crews arrive. Make sure you maintain a safe distance from the ESS and monitor. In our large commercial settings, you might have a remote fire department connection where the first in engine may need to supply water into that fire department connection. And each manufacturer will have a recommended time of the battery pack to cool down, and it can be near a full work cycle of 12 hours or more. In some of our large installs, these have been length of incident. If you haven't noticed, do you see where more and more of this is coming up? That these incidents are now getting longer and longer. And what is that impact going to be on us, the fire service, in our response crews? And it's really part of that open dialogue that we need to continue to have with our elected leaders, with our bosses, with our crews, and our battalion chiefs, and everybody involved. So how do we get crews recycled and back in? Who's covering the calls while they're tied up, et cetera, et cetera. But think about that. You imagine in some incidents with large ESS were multi-day events. We don't get those very often, at least here in the Midwest, but really it's important for us to understand this potential that can be there. Water spray is always, whether it's EV or it's in the ESS, is always the preferred response. And if a fire is not developed and only smoke is visible, take a defensive stance towards the system and be prepared to spray water with full SCBA. If a fire develops, take a defensive stance towards the burning unit and apply water to the neighboring enclosures and exposures. Maintain a safe distance, and in some of our commercial settings, it's 300 feet. Now, when I bring up a commercial setting, if your community is protecting something that has multiple ESS units, that is part of a commercial installation, one of the vital part within the code development process and the code process is that we have a response guide that you've been incorporated into. Your community, your first in crews should be very well versed. And I think about this from an energy standpoint. If your companies were dispatched right now to an electrical fire on a substation that probably every single one of our communities have, would our crews enter into the distribution facility without somebody there from the energy company? And the answer should be resoundingly no. And I think the same would be in place as it relates to large areas with ESS. You know, as we respond, they will probably have been alerted through their battery management system that an event was going on. And as we get there, now we're going to have to take some decisions, but we're going to allow the unit that's on fire to burn, and we're going to cool the exposures. And here's the hardest part in all of this that we're talking about. Part of what we may have to do as fire chiefs, as leaders in the fire service, is redefine what success is. And success might be is that we don't have a secondary incident, that it didn't spread to another unit. And that's a little bit different for us because for the most part, when something's on fire, I know we put it out. And in this case, we're fighting chemistry. We can't put it out. And so how do we limit the impact on our community? How do we limit that exposure? And so that patience during response is vital, both in ESS, EV, or any of our large battery type things. And so make sure you get to the response guides. You'll see that the response guides, I pulled up the Tesla ESS one here, and you can see that they have all sorts of different things for not only their power wall, their power rack, their mega pack. And you can get into all the different things that they recommend, both from PPE, if a fire develops, to if smoke is showing, and the like. So a couple response thoughts, and we didn't spend a ton of time, but our crews are going to be faced more and more every day with batteries in a fire event. And it may not be the cause of the fire, right? Just think about how many times we have an incident where there was a scooter in the garage that was battery powered. How many times could we go on an event where there's just, if you go to a big box retail right now, and if there was a fire in the tool section, pretty sure a couple batteries are going to be involved. So let's just think about this and you could play through these what ifs after we get into the training. But when you go to a smoking ESS unit that's in an attached garage, what are our response priorities, right? How do we properly ventilate? How do we make sure that we're protecting exposures? What's the number of resources we need, and how long might this take? Because if we probably go back a couple slides here, this is the part: patience during the response. Because we're going to need to get on the phone. We're going to need to get some partners to help us. But more importantly, that smoking ESS unit in a garage is probably going to have a unit tied up for half a day, at least. Even if it's just 1 or 2 cells, the cells go out, we disconnect the power, the unit cooled down. That some time has passed for us to get to that point. And so there's some things that we could keep talking and going through, but one of the important parts is with our ESS is having a decommissioning plan. So if there is an event, how are they going to bring it down offline, and whose job is it to get everything kind of back to status quo? And you think about it, that's going to be a little bit more difficult for us in the residential setting. I think the commercial setting is going to be a little bit easier, but really for the most part, the residential setting is going to be a little bit trickier in that decommissioning. Now, real quick as we wrap up, and then we'll go through some questions with Richard. There's a lot of other fires happening, and as fire service, one of the things we need to do is help support our community. We do not need to have our crews tied up on a transfer trash facility fire, but it's going to continue to happen until we can really work to educate. So how do we challenge our community risk reduction folks? How do we challenge our fire prevention folks to really start to change some of our messaging on proper disposal of personal electronics and things powered by lithium ion batteries, right? Those mobility devices, have you thought about this for a second, right? If your DeWalt battery goes bad on your Sawzall that is on your fire engine, and it's under warranty, and you take it back to your favorite big box, do you ever wonder what they do with that thing? Right? Just think of the logistics that's happening in every big box right now across the United States. That's traditional recycling, right? That we probably need to collectively work with our community to help better educate everybody in how we make sure we're not creating secondary events. And then on the other side is, how do we get people to stop throwing things in the trash that should be recycled that are of battery nature? And I really think that that's where we're going to see it. One of the things that happened here in Brighton was a collection point that was taking batteries in. They collected a whole bunch of lithium ion batteries. They were put onto a semi, and they were heading out to California to get recycled at the end result. That semi caught on fire 5 miles from its facility, and it presented as white smoke coming out of a trailer. Well, just remember, anytime that batteries in a box go into thermal runaway, it's bad. Batteries in boxes is bad. Well, batteries in the back of a semi on fire is not a good thing. And right, it created a pressure event, right? We had a lot of flammable gas within there, and it actually bent the trailer, but created us a very significant incident on the side of a freeway. And so if you think back to one of those first slides I had that showed that whole circle that we're dealing with, our crews are seeing it in EV. They're seeing it in mobility devices. They're seeing it in transfer, right? We're now seeing it as the products are moving to their final destination as well. And it's just something that's going to increase in frequency as the number of devices keep increasing. But, think about this for the most part. The new iPad came out today. And if you pre-ordered it, you got it today. So there was a lot of lithium ion batteries in transit all across the United States and abroad today, right? As part of a very big movement. And for the most part, it was relatively safe. I haven't seen anything come across the news, right? So when we think about our collective approach, how do we support our crews? How do we start to support our community? And so get your CRR people engaged, develop a plan. Who should we be talking about with our defensive approach? what CRR activities on batteries can we initiate to make sure we're reducing that impact of fire, specifically in those secondary events? And really, this is a collective team approach. So we're going to open it up to questions. I think Richard's going to come on.
Thank you, Chief. Great presentation as always. And thank you for everyone that's on our event today. We've got quite a few questions out there that people have posted. I've tried to answer some of them directly, but I think some are pretty important for everybody to hear. One of the questions was about recall advisories on e-bikes and scooters. I posted in the chat a link to the CPSC recall notices, and there's a whole litany of list of different recalls that have been around the country. So it's probably best to just go to CPSC for those consumer products as we look at those various topics that are out there. And I'll just go back to your highlight there. Some of the questions, though, that we haven't talked about, we're going to touch on real quick. First, has anyone ever used Cellblock EX for operations is one of the questions, which kind of goes to the foam question also, a different additive to the system, and I'll cover those next.
Yeah, so Cellblock, a great product for use in smaller applications. It's not for the ESS. It's really, once we've gotten a lot of the stored energy out, Cellblock is a great way for us to start to package that battery for packaging. Now, the question on F500 foam, I think F500 foam has some potential when you have direct access to the cells. But keep in mind, both in ESS and EV, we do not have direct access to the cells. And so that encapsulator goes back to that statement that all the manufacturers say, don't use foam. And so I think the F500, if you have a battery production facility, you have a battery plant, probably a good idea for you to have the F500. And probably Cellblock should be part of your secondary response as it relates to maybe, what do I do with this mobility device that was in an incident, and how do I properly dispose of it?
Tied to that, Chief, was a question about compressed air foam for Class A application.
I don't think much testing's been done by anybody yet in CAFs and battery. I think that's one of those areas we've got to work on.
Thank you. So an environmental question has come in with having to flow such quantities of water. Kind of speak to that hazard and environmental runoff control.
Yeah, for the most part, in our smaller EVs and smaller battery-related fires, the runoff is negligible. It's the studies are showing that it's very equivalent or less than a current vehicle fire. Really, where we have to be careful is when you're flowing 10 to 20,000 gallons. Some people are even seeing a higher rate of chlorination in an area that it wasn't used to. So I think we're going to keep pushing this to get more technical resources. And if you stay in tune to the IFC's webpage on EV and battery fires, I'm sure we're going to be pointing to some resources in the near future on this.
Great. So this question crosses between both electrical vehicles and ESS systems for home charging. And if the vehicle's plugged in, can we unplug it during the incident?
Yeah, that's a good question. I know that when an EV vehicle is plugged in, the good thing is most of our people aren't going to drive away. The vehicles will not let them drive away. The unplugging part, so when I said, hey, go to your dealers and figure out how these things work, this is a great question to start talking to the manufacturers about and reading their response guides. So everybody's a little different, but a lot of our plug-in right now, they make them so that you can't unplug them, because some people like to unplug them while you're charging. And so go and check it out. Each manufacturer is a little different there. But to me, if we have an incident while a vehicle's charging, shut the power off to the charging equipment.
Great. That leads us right to this next question for residential storage packs. Do they have shutoffs? And I think this goes to your code question earlier, but have they been installed?
Yeah, the commercial setting's a little different, but in the residential setting, we should be pretty good at this. Find the main circuit disconnect, shut the power off. But it's just like an EV. The stored cells still have high voltage energy, okay? We can never dissipate that energy in those cells. And so we have to treat it as charged.
Great. One of the questions or asks was, will we be posting the webinar? And yes, we will be posting not only this webinar, but the previous webinars are already posted on the IFC webpage for events, and you can download the recordings so that you can share it with your members. And we'll be glad to continue to push those out. One of the other questions that came in was about a vehicle extrication incident in operations and crash. And, what are there any safety precautions that should be considered? Obviously, probably looking at the fire situation, the electrical, potential that are sitting there.
Yeah, EV vehicle extrication. I would highly encourage you that you create that battle rhythm with your crews when they arrive, inner outer circles, safety, crib the vehicle, and then when they've identified that it's an EV, right, relay to incoming crews that this is a X EV and see if they can get the response guides pulled up. But that key is we can't be cutting into that bottom wedge, that bottom part of the vehicle where that high voltage is. Never cut orange, and just, I can't emphasize enough the peek and peel concept, right? So I think we started this as we had more and more airbags introduced. It's hard to believe that I've been in the fire services as long as I have, but when I started, we just started cutting, and then it seemed like more airbags were coming in, and we started this peak or peel and peak, right? You're going to peel off. If you're going to cut into that A pillar, you're going to peel it off and look. Look at that response guide and see. But most of the manufacturers, when we're doing door pops, taking doors off hinges, those types of things, I think our standard stuff applies. We're good. It's really when we get those fire department things that we're used to, right? That vehicle upside down up against a Jersey barrier, where our crews need to get creative to get the human out. I think that is vital that you have the response guide and you give it a quick look, because there's no doubt we can't be cutting dashboards to do maybe displacements on dashes and stuff like that. So just that we've got to stay out of that high energy battery pack. We don't want to create ourselves an event, and we definitely can't cut orange.
Great. I know you covered the IDLH and production of a hazardous atmosphere. Could you kind of go over that and maybe just a brief overview of what occurred in Surprise, Arizona?
Yeah, Surprise was a tough one because, right, the crews got dispatched to this ESS. They felt like they really had patience, and the ESS we're making today are much different than the ESS that was installed then in Surprise. And so really the crews had a lot of patience, but we had a discharge of a suppression system and, open door, and we had an event which, really took a toll on a couple firefighters. And I think really for the most part in us, when we have an active event in that energy storage system, a building, it's patience, working with the manufacturer, making sure that we're utilizing everything from the battery management system to the response guide to the field personnel, and we're making good decisions because, obviously we don't want to see a repeat, but there's a lot of older ESS systems out there. And I can't stress enough how important it is that you have a response plan built. If you have a large ESS, like we saw down in Surprise, and it's been in for a couple of years, make sure that you have a plan, and more importantly, put some pressure on your fire marshal's office. When we look at our newer codes in the 2024, we've actually put a retroactivity requirement for a hazard analysis on those style buildings. So it's just another tool out there for the fire service to make sure we're properly prepared.
Great, thank you, Chief. Thank you for all the questions, everyone. As we wrap up today's event, we just wanted to share some of our future IFC events. Symposium in the Sun in Florida and Clearwater is just a few weeks away, and VCAS is reporting that they're already sold out, but that's a great event. Wildland Urban Interface Conference in March in Reno. Again, that's an outstanding time to brush up on all our wildland tactics. And the Community Risk Reduction Leadership Conference scheduled for Murfreesboro, Tennessee this year, March 23rd and 25th. And please come learn with other community risk reduction leaders around the country at this event. And it's a great time to share and learn. As this event is recorded, we'll again be posting it probably by the end of the day. And if you have additional questions, please don't hesitate to email Chief O'Brien or myself, and we'll be glad to try to get those answers. and your input is important because it brings us closer to what's happening out in the field every day. And this brings us to the conclusion of our webinar series. Chief O'Brien, I'll give you the last word.
No, I think I appreciate everybody from being here today and the support of the IFC, and you, Richard, for helping us continue to try to prepare the fire service. We openly appreciate all the dialogue, and just know that we're working to make sure we continue to provide you all really good resources. So hit us up with those questions so we make sure we come back, but look for the toolkit coming in the near future.
Thanks again, Chief, and thank you, everyone, and please enjoy your day and have a safe afternoon.